The Apollo 13 mission stands as a testament to human determination, innovation, and teamwork in the face of unprecedented challenges. Often referred to as a successful failure, this space odyssey captivated the world's attention and pushed the boundaries of human exploration. The mission's mysteries lie not only in the technical malfunctions that threatened the lives of the astronauts but also in the ingenuity that ultimately brought them home safely. This exploration delves into the intricate details of the Apollo 13 mission, examining the enigmatic events, the incredible problem-solving efforts that ensued, and the lasting impact on space exploration. The Apollo program was NASA's response to the ongoing Cold War-era space race. With the Soviet Union's early successes, including the launch of Sputnik and the first human in space, Yuri Gagarin, the United States aimed to assert its technological prowess and secure its place as a global leader. Apollo 11's successful moon landing in 1969 was a defining moment, but subsequent missions faced dwindling public interest. By the time Apollo 13 was slated for launch in April 1970, moon missions were becoming routine. Apollo 13's crew consisted of Commander James A. Lovell Jr., Command Module Pilot John L. Swigert Jr., and Lunar Module Pilot Fred W. Hayes Jr. All three astronauts had previous experience in space, with Lovell having flown twice before. Swigert, however, was a late replacement for Ken Mattingly, who was removed from the mission due to concerns about his exposure to German measles. Apollo 13's primary objective was to perform a lunar landing in the Fra-Mauro Highlands, a region rich in geological significance. The crew was to explore and gather samples, contributing to our understanding of the moon's composition and history. Additionally, they were tasked with conducting various scientific experiments and photographing potential landing sites for future missions. Apollo 13 launched on April 11, 1970, with initial stages proceeding as planned. However, on April 13, a routine cryogenic tank stirring procedure triggered an explosion in the service module. This explosion compromised the oxygen and power supply systems, endangering the lives of the astronauts. The phrase, "Houston, we've had a problem here," spoken by Lovell, became synonymous with the crisis. The crew, NASA's mission control, and engineers on Earth faced the daunting task of devising a plan to bring the astronauts back safely. Drastic measures were implemented, including shutting down non-essential systems, navigating using the lunar module's propulsion system, and rationing supplies. The lunar module's life support systems, designed for 2 astronauts for 2 days, had to support 3 astronauts for 4 days. Engineers on the ground worked tirelessly to develop a power-up sequence allowing the astronauts to restart the command module's systems just in time for re-entry. This involved navigating by the stars, conserving power, and executing a complex series of maneuvers. The lunar module played a crucial role as a lifeboat, providing life support and propulsion capabilities. With the command module's communication systems disabled due to the explosion, the crew and mission control had to rely on the lunar module in ground-based radio communications. This necessitated careful coordination and creative solutions to ensure that critical information was transmitted accurately. Despite the odds stacked against them, the crew successfully re-entered Earth's atmosphere on April 17, 1970, and splashed down in the South Pacific Ocean. Their safe return marked the end of a harrowing journey that showcased the resilience of the human spirit and the power of collaboration between astronauts, engineers, and mission control. After the Apollo 13 mission, NASA conducted an extensive investigation into the causes of the explosion. The inquiry led to significant design and procedural changes, including improvements to the oxygen tanks and adjustments to mission protocols. The lessons learned from Apollo 13 saved subsequent missions and contributed to the overall safety of space travel. The Apollo 13 mission is celebrated as an exemplar of human ingenuity and determination. It highlighted the capacity of individuals to adapt, improvise, and overcome seemingly insurmountable challenges. The story of Apollo 13 continues to inspire generations, demonstrating the remarkable feats that can be accomplished through innovation and teamwork. The technical innovations and problem-solving strategies developed during the Apollo 13 mission had lasting effects on space exploration. NASA's approach to risk assessment, engineering practices, and crisis management evolved, influencing subsequent missions such as the Space Shuttle program and the International Space Station. Apollo 13's captivating story has been immortalized in various forms of media, including books, documentaries, and the 1995 film Apollo 13, directed by Ron Howard and starring Tom Hanks as Jim Lovell. These adaptations have further propagated the mission's legacy and the remarkable human spirit it embodies. The mystery of the Apollo 13 mission lies not in the failure of equipment but in the success of human collaboration and determination. The challenges faced and overcome by the crew, engineers, and mission control showcase the remarkable ability of individuals to adapt and innovate under pressure. Apollo 13 serves as a reminder that even in the face of adversity, the pursuit of exploration and knowledge knows no bounds. The lessons learned from this historic mission continue to resonate, shaping the future of space exploration and inspiring generations to reach for the stars.